Alright, so I'm putting together a little video so that you can establish the difference between physical changes that we might see in the science classroom and chemical changes. I think this video will be a big help when you're working on your physical chemical project later this week, and also we move on to chapter 3 and learn about mixtures. This will be a good video for you to use, a good tool to help you out. So anyway, notice that these are color-coded. Facts that will fall under the physical change category are going to be blue. I'll just use that color coding, even if we do any experiments in the classroom. And then green, I'll keep it chemical. So if you see any bullets that go under here, they will match with the chemical change green heading. So let's focus on the left side first. Physical change is one sign that a physical change has taken place is that the particles of the substance have not changed. The chemical composition hasn't changed at all. So if you think, for example, water in a liquid form freezing and turning into ice, solid, the H2O molecule has not changed in any way, it's just changed its behavior. So that's one sign of a physical change. Another sign that we could look for, physical changes are usually reversible. There are a couple exceptions that sometimes throw people for a loop, and I'll kind of clarify those exceptions in a minute. But if you think especially phase changes, like liquid water turning into gas, if it condenses, it can form back into a liquid again. So they're usually reversible. And here are some examples that will help us categorize. When we look at some real-life examples in a minute, we can use this example list to help us establish if it's a physical or a chemical change. Phase changes, I've been talking about that for the last couple minutes. And then these examples, any ripping or tearing or crushing, you crush an aluminum can, you tear a piece of paper, the composition of those materials has not changed. The chemicals that are making up that aluminum can are still aluminum. They've just they haven't changed their chemical setup, but they're not really reversible. It's not easy to reverse a piece of paper being torn. So that's the one. These are the couple exceptions here that sometimes confuse people. Moving over to the chemical change side, the first two bullets are basically the opposite of the first two bullets for the physical changes. The particles of the substance have changed. Their chemical composition is different. If you had water molecules that reacted with some acid or base or some sort of substance, and the elements, the atoms that make up those materials change their arrangement, that would be a chemical change. When we go into chemical reactions, when we learn about chemistry in a few weeks, you'll be able to see that firsthand. And chemical changes are usually not reversible. If some sort of change happens, before the break we saw a marshmallow being burnt by a match. You can't get that nice squishy marshmallow back. It's now permanently changed. You can't go backwards. Another example of a chemical change, or another sign to look for, sometimes those chemical reactions will create heat. And there's another video that shows an exothermic reaction, and I use that same word there. So if the reaction creates heat, it's exothermic, and sometimes reactions will absorb heat, and those are called endothermic. Reactions that absorb heat create cold. If you think of those ice packs, if somebody gets a bump on the head and you get that little package from the nurse maybe, and you break up that package, or you crush whatever's inside and it starts getting cold, and you put that on your wound or on your bump, that is an endothermic reaction. It's creating cold. It's absorbing the heat. So now that we have our two lists, two very general lists of signs of either physical or a chemical change, let's see if we can look at maybe 3 or 4 examples and decide, does it go in the chemical category or does it go in the physical category. So the first one you probably learned about when you learn about the rock cycle, maybe in 6th or 7th grade. One way that a rock can change is through mechanical weathering. This happens on the sidewalk, it happens on the driveway, and in this type of mechanical weathering, I'm going to guess that over time rain or water or whatever has seeped into the pores of the rock, and that water has frozen and expanded, and then as the weather gets warmer, maybe that ice melted, and the process repeats itself over and over again. So let me see. I'm thinking chemical because I know I can't get that rock back to normal. It's not reversible. However, I was talking before about some phase changes in water, and also the particles of this substance, the particles of this rock, if it's a granite rock, the composition is still the same. It hasn't changed. It's changed its shape a little bit, but if we were to look at the atoms that make up this rock, they would not be different. So that's why mechanical weathering would best fit under the physical change category. This rock has been physically changed. Here's another example. Something we've seen a bunch of times. Here I have a little gizmo set up. Boiling water. So we have liquid water. We are adding heat. The temperature is probably at 100 degrees Celsius, and I see the water molecules here in the liquid form kind of bouncing around. They're sort of close together, like a medium amount of attraction. And then up here I'm seeing the molecules of water in the gas form. Less attraction, more energy. They have gone from liquid to gas. We call that vaporization. So let's see, is this a physical or is it a chemical change? I'm looking over at the chemical side again. Let's see. A gas is created. Bubbles are created. Creates heat. That's 3 bullets that seem to connect to this picture that I'm seeing. However, if I look a little more closely, the reaction creates heat. Well, water boiling really didn't create any heat. Remember, we had to keep the Bunsen burner on. We had to add heat to that system. So that really doesn't apply to this picture here. So this reaction does not create heat. It does not absorb heat. We are adding the heat. So that's not going to apply to this picture. A gas is created. This is a tricky one. The gas was created, but there was also condensation. The kind of gas that I was referring to on this list would be like smoke, or when we saw the zinc and hydrochloric acid combine. If you look in that other video, there was like a smoky substance. I think that was hydrogen that was coming off of the test tube there. Bubbles do form, so I'm a little bit stumped right now, but let me look over at this side. Let's see here. Usually reversible. Boiling water is reversible. The water molecules can go back to the liquid form. Boiling water is a phase change, and the identity of these molecules has not changed. That's why this gizmo is such a great tool for science teachers to use, because you can see what the molecules look like. H2O. So you see this H2O molecule looks the same whether it's in the gas form or in the liquid form. It's just behaving differently. So definitely example 2 should fit under the physical change category. Let's do one more together. Let's see here. Oh, something that we saw in science, I think either on Thursday or Friday. I actually have a video clip from somebody, period 7 took this video. We mixed Alka-Seltzer, and the main ingredient in Alka-Seltzer is something called sodium bicarbonate. This is the compound. These are the atoms that are inside of sodium bicarbonate, and this of course is the formula for water. You're probably familiar with that, and I'm setting this up for you because later when we learn about chemical reactions, we're going to see how the atoms rearrange when they have a reaction with each other. That's really important. The chemical composition of the products might be different than the composition of the ingredients. Another word for ingredient is reactant. So here's a video I think Anthony Ruggiero took. Alright, there you go. So clearly you have bubbles that were formed. You have a gas that was created. I don't know about the heat. I don't know if there was any heat being produced or absorbed, but I do know that it's not reversible. I can't get that nice Alka-Seltzer tab back. So that's definitely a chemical change. Adding those two reactants creates a chemical change. And here's one more I want you to think about and see if you could try on your own. We did an example, or I had a sample of dry ice. And it was, we put it in like a container of green water, and we held it with the tongs, and that dry ice was going through a change. It was going from solid directly to gas. It was sublimating. So based on these two lists here, your physical change bullets and your chemical change bullets, which do you think sublimation would fall under? All right, thank you very much.